Here, and in this video we're going to be exploring an example of investigating the plasticity properties of a soil. So let's go ahead and get started. Here we're being told that we're given a clayey soil that has a clay size fraction of 47%. Liquid limit and plastic limit test results are summarized below, and we're being asked to determine the following. First, the soil's activity. Second, the type of soil according to the Casagrande plasticity chart. So let's make sure we know what we're looking at first. First, we have a table here of liquid limit data, which gives us the number of blows and then affiliated moisture contents, okay? Then we have plastic limit data where we're given runs, and then for each run we have a different plastic limit value. Now, when we say we have these different runs here, this means that each one of these represents one of those threads that was rolled and crumbled at the appropriate diameter, and then a moisture content was obtained, which represents the plastic limit, and there was 3 of those given, okay? So to get started in calculating the soil's activity, let's go ahead and say solution part A, activity is given as the plasticity index divided by the clay fraction. So we're going to say F sub clay. I'm going to go ahead and make this a subscript. And again, this is the general calculation for activity. And if you remember, activity represents a soil's potential to swell. So a high activity, usually greater than 1.0, means that the soil has potential to swell when it's in the presence of moisture. Okay. So do we have F clay? Absolutely. That's the 47% that was given to us, right? What about the plasticity index? Do we have that? Not directly, but we have the information we need to get it. So we know that the plasticity index is equal to liquid limit minus plastic limit, okay? Now let's get the plastic limit first because that one's pretty straightforward. We're just going to say the plastic limit is the average of these 3 plastic limit runs, okay? So there's our PL. Now, what about the liquid limit? Well, we need to remember, what is the definition of the liquid limit? Well, the liquid limit is the moisture content when our soil closes a 12.7 millimeter gap, or about half an inch gap, at 25 blows when we perform the liquid limit laboratory experiment using a percussion cup, okay? So how do we get that information out of this table here? If you notice, none of these blows are 25 blows. They're all around 25 blows. Well, what we're going to do is use this data to draw a flow curve, okay? And we're going to do that by saying insert, and then we're going to grab a scatter plot here. And if you remember, a flow curve is generated whenever you plot moisture content on the vertical axis, and then you have the number of blows on a horizontal axis. Okay, so we're going to label our axes here, all in Excel. Our horizontal axis is the number of blows in, and our vertical axis is the moisture content, which we call W, and we put it as a percentage there, okay? Now, we typically express the number of blows on a logarithmic scale. So I'm going to go right-click and hit Format Axis, and I'm going to put this on a logarithmic scale. And this is log base 10, okay? Now, just to make this look a little more user-friendly, I'm going to set my minimum to 10. And I'm going to go ahead and right click again on the horizontal axis, and I'm going to add minor grid lines just so I can see things a little bit better. And then on the vertical axis, I'm going to right click and hit Format Axis. And on my minimum, I'm going to set that to 30 just to spread the data out a little bit. Now I can see things a little bit better. So the best fit line, let's move this around a little bit so we can see it better. The best fit line through this data will give us the flow curve. Now, if you were taking a paper exam or a computer exam, even if you have a problem that's related to this on the FE exam, whenever you have the graphical representation of the flow curve, you're likely going to have to eyeball it. You're going to have to read the information out visually. So I would need to recognize that this is 10, and then this line represents 20, and then 25 will be somewhere about here, and I would come up to where a best fit line would be, and move on over, and I would read off a moisture content, in this case, somewhere between 36 and 38, okay? So again, on a paper-based or computer-based exam, you would probably have to read this visually, okay? But in our case here, we have data in Excel. So we can actually take a more mathematical approach to getting our liquid limit. And here's how we're gonna do that. I'm gonna right-click one of the data points. I'm gonna add a trend line. Now, when you come over here, your default trend line is linear. Remember, our number of blows, this horizontal axis, is on a log scale. So you don't want to use a linear trend line here. You want to use a logarithmic trend line. Remember, when you use a logarithmic trend line on semi-log paper, you're going to get a linear relationship or a linearized logarithmic relationship. Now I'm going to display the equation on the chart. So this is my linearized logarithmic equation where y represents moisture content and x, which is our independent variable, represents the number of blows, okay? Now, again, I can visually get the liquid limit. I can eyeball about 25 here, come up, come over, and I'm going to see I'm a little bit above 36 for the liquid limit. But because I have this data and I have it in Excel, I'm going to do this more mathematical approach where I'm going to say liquid limit equals, and I'm going to input this trend line equation into this cell. So that's going to be negative 7.181 multiplied by the natural log of what? Well, 25 blows, because we're looking for the moisture content at 25 blows, which is the liquid limit when you are using a flow curve like we are. And then I'm going to say plus 59.307. And there's my liquid limit, 36.2. Now I can clearly get my my plasticity index. So my PI is just going to be equal to my liquid limit minus my plastic limit. Okay. Now, finally, I need my activity. That's what I was asked to do in this problem. So I'm going to say my activity equals, and that's that plasticity index divided by the clay fraction, which given above here in the problem statement was 47%. So we're going to say divide by 47, and we get 0.4. So we're going to say since this is less than 1.0, this soil is inactive. Okay, so it does not have a whole lot of swell potential in the presence of moisture. All right, so that's part A. What about part B? Part B of the problem said determine the type of soil according to the Casagrande plasticity chart. Okay, now the Casagrande plasticity chart, you can find it in all kinds of great resources. It's in pretty much every single geotechnical engineering or soil mechanics textbook that you might use as a student. It's also in the FE reference manual, and I think the most recent FE reference manual right now is version 10.3. So it's in the geotechnical section of that. If you need to use that when you're studying for the FE exam or taking the FE exam. So I have a copy of the plasticity chart that I generated myself. I actually plotted it myself in Excel separately, and generated this nice figure here. So how do we read this plasticity chart? Well, along the horizontal axis of the plasticity chart, we have liquid limit, and then the vertical axis is plasticity index. And if you remember, we have an A line and a U line, right? So the A line has this equation, PI equals 0.73 times LL minus 20. And then the U line is PI equals 0.9 LL minus 8, okay? And then we have these different regions here, these different zones that help us identify different soil types, okay? So what do these designations mean? Well, a C in front as a first letter designation means clay, okay? And then L means low plasticity. So for example, if we're in this zone, that's a clay of low plasticity. Or O stands for organic. So that could be an organic clay or silt of low plasticity, okay? What about this zone down here? M stands for silt, okay? Now, if you have a CL or an ML, again, that's a clay of low plasticity or a silt of low plasticity, and these would be inorganic. If it's organic, it's going to start with a letter O. So down here, an OL again would be an organic silt or clay of low plasticity. What about the letter H? That would stand for high plasticity. So for example, a CH is an inorganic clay of high plasticity, and MH is an inorganic silt of high plasticity. Okay. Now this shaded little slice right here indicates a dual symbol or a dual designation, CLML. So that's kind of like somewhere in between a clay of low plasticity and a silt of low plasticity. So that's kind of a recap of how you would read this. So what do we do? Well, we're going to enter in with our liquid limit. We got that earlier as 36.2, and then we know the plasticity index is 19.6, right? So 36.2, I'm going to insert an arrow here. 36.2 is going to be right about here. Okay, and I'm going to come up, and I can make this kind of a more noticeable color, I guess, orange. And then the plasticity index was 19.6. So I'm going to go right about here, come over. Let's make that a more noticeable orange color. And let's make a little adjustment here. And so I'm landing right about here. Okay. So if I insert, if I want to, go a little above and beyond and put a little dot there, I land in this region, which is a CL or OL. Okay. So according to this is going to be CL or OL, which stands for inorganic low plasticity clay, or low plasticity organic clay or silt. Okay. So that's the region I'm in according to this plasticity chart. And this is not, I want to make a note here, this is not a full-blown soil classification. Okay. If you want to fully classify a soil, you would follow some additional processes given by one of the soil classification systems, such as AASHTO, USCS, or USDA. So this part is not meant to be a full-on soil classification process. This is just meant to illustrate how do we utilize the plasticity chart when we know some liquid limit information and some plasticity index information. So hopefully you found this video helpful. If you did, please hit like and subscribe, and we will see you next time.